5:30 a.m.
Hello everyone. Oh, hi. Hello everyone. How are you all doing? Hi everyone. Hello everyone. A little bit delay we had for some technical glitch. I'm so sorry for that. How are you all doing? Today's live is going to be very interesting. I tell you that because I'm going to ask you to throw some very random questions, very irrelevant questions, let's say. So how are you all doing? How are your summer vacations going, or have they started or have they not started? How is everyone? This is the first live of our class 9th, and you all who have been like transferring from 8th to 9th, almost the first phase is quite done. You have been enjoying the vacations. I can see that in all other lives as well. But yes, this live is going to be really interesting because the whole book is changed. CBSE has thrown, or rather NCERT has made quite some changes in this book, right? So you must have seen, I've put up a video as well explaining all the new chapters, explaining all the new strategies on how to study science, how to study this new book, and how this can be a great turnover. I'll say I really pretty like the book. Okay. Hi everyone. We are going to start the very first chapter, and the very first chapter is simply explain us the world of secondary science. You know, you have transferred from middle school, let's say from 8th to secondary school now, that is 9th, you are a senior, and your science is also a little bit of senior now. Okay, so it's going to be a little bit difficult. But with this book, we are mostly going to focus on how to tackle science in a really good way. Okay, so in this live, we are going to see that as well. Fine. So let's start this. How are you all? There are 14 people and I cannot see your chats. If you all are okay, give me a thumbs up. We can start the chat. We can start the live as soon as you all guys let me know that you all are ready to learn. Okay, so basically the science we are going to study today talks a little bit more about how to study it, what is science, and why we have to study this particular topic. Right, you have all these doubts maybe that, ma'am, I was the kind of student, you know, that used to question everything. Like, ma'am, why do I need to study evaporation? What is its use? So this book, and in these live sessions, in these recorded videos, one shots, we are going to learn first about why to study science and how to then explore science, hence the name exploration of the book. Right, so starting with what we are going to study in class 9th, and how exactly do you think we can study science? Throw any random questions, any doubts you guys have, you can let me know. We can go with that as well, right? Okay, so first of all, in this we are going to very clearly see how science works. Right, I did like masters in science, masters in physics. Okay, so science is a very dear to my heart. So it's really interesting when people actually ask me, ma'am, how this machine is actually working. So that is what we are going to see in this particular chapter, in this whole science. Next, how scientists think. You know, when you want to learn science, the most basic thing is to understand how the creator worked, right? So how the scientists work, bacha, we are going to see all of them. Are you excited or not? How's the josh? Because mine is really high. New book I have seen, and the one thing it talks about is how the scientists work. So imagine you are studying how Isaac Newton thought about gravity by seeing just an apple, how Albert Einstein gave so many such a big photoelectric effect by just looking at one maybe solar cooker, or maybe anything. A sunlight gave us a solar cooker. That's crazy, right? So we are going to see all of that in this video, right? So next this book talks about is actually how do we study science. Now you know how scientists think and how to start how this science works. Now we have to score marks as well, right? So we will study how do we study science and a little bit more deeper on are these just facts or are there more to the science, right? Are there just plain facts or more science? So if you are ready, give me a thumbs up in the chat and we can start the very first chapter, that is exploration, entering the world of secondary science. Okay, let's start with the very first, that is, okay, this actually is a bonus for all of you who will stay at the end. I will give you the exact strategy to study physics, chemistry and biology. Okay, now starting with the very first thing, that is your models. Okay, let's say I stand here, okay, and you click a screenshot of mine. And you think from that screenshot you can understand, okay, ma'am has specs, ma'am has long hairs, okay, ma'am, but okay, you have a screenshot and you can understand ma'am have long hair, specs and all those traits of mine. Ma'am is wearing a black t-shirt, right? Okay, Tanush is saying thumbs up. Okay, great, Tanush. So, but can you from that screenshot understand how I speak, or even what I teach, or if I am a Kaleshi person or not, or if I am an overthinker or not, right? Can you decipher all of that? Can you decipher all of my complex traits from just my screenshot? You can't, right? You can't possibly think that ma'am didn't sleep last night. You cannot decipher that from my screenshot, right? Because all the complexity of mine has left the chat when we took a screenshot, and that screenshot, my friend, is our model. And models are such a cute things in science, right? Because we are going to study models everywhere. Models of heart, models of sunlight, models of plants, models of animals, models of force, friction. We are going to study graphs. What are all those things? All those things are models of something really, really complex in this side, right? So what is a model? A model is simply a simplified version of reality. So my screenshot is a simplified version of my complex reality. Understood? Give me a thumbs up if you understand. Give me a thumbs up if you understand what a model is. And why do we do that? To make the sense of this complexity. If someone looks at me and all they can see about this, that she didn't sleep last night, she is Kaleshi and all, but the picture is not to depict my characteristics, right? It is to what kind of t-shirt I'm wearing or specs I'm wearing. So it makes all that complexity leave the chat and only gives us the model. So model is, that screenshot is a model of me, right? Similarly, you have a globe. Globe depicts what? Globe depicts the model of Earth, right? Okay. Globe depicts the model of Earth. Now the globe does not tells us ki where is the what is the complexity or population density of India. Hi Keshav Malik, how are you? Welcome to this live. Hi Chandan, Uttarakhandi. Are you from Uttarakhand, Chandan? Welcome people from all over India. I was telling about the globe. So we have people all over India, all over from India, right? So India on the globe, does that tells the characteristics of India? How much population India has, or who is the Prime Minister of India? Does the globe tells us? Because that is all the complexity of India, right? But globe is a simplified version of our world, right? Understood? Great. I can see lots of people studying, right? Yes, you are from love from Haryana, Keshav. Love from Punjab, Keshav. I'm from Punjab. Love from Punjab too. Your neighbor here. Okay, so now we are studying about models, right? So it's a simplified version of reality. Now you have to depict an atom, right? I am made up of so many atoms, and in that atoms you have electrons, you have protons and neutrons, blah blah, yada yada, what, right? But how do we depict an atom? We depict an atom with a dot, right? So that dot is model of an atom, right? When we make next year, you'll have to make the diagram of heart, right? It's like a little bit complex, but I'll make it simpler, right? So you'll have to depict the model of heart. So when you draw the diagram of heart, do you see how many number of cells are there in the heart? What are the tissues? Where are those? But rather we studied about the vessels of the heart, the different four quadrants of the heart, right? So we to leave all the complex structure out and to study just about the heart and not about the cells in the heart, we make it a simplified version of heart, right? And that is what our models are. Can you tell me some of the models from real life? Can you think of anything? Keshav, Chandan, Tanush, all of you guys, let me know some models from your real life, your daily life, that you think are a simplified version of realities. Like my picture is a simplified version of my personality, right? So like that, what are the models you can see from your daily life? This first chapter, na beta, this is going to be very interesting, and I want all your participations because you have to give me so many weird questions now. Yes, not answers, so many weird questions. I will ask you a question and you will give back to me a lot of weird questions in return, right? Okay, let me know. Although I do think that you all are enjoying your summer vacations, but fine, we are in secondary school now, so we have to study in our summer vacations as well, right? Okay, great. Now moving on to next thing we have is what this book talks about, right? This book, when you imagine you on the place of Newton, would we have gravitation today? Or me in the place of Newton and an apple fell. I'm like, oh, sweet apple, I'll eat it. I'm always hungry, right? So how a scientist think? How do you ask questions? This book talks about that, right? The first step you take towards becoming a scientist, a physicist, a chemist, a biologist is asking questions. You have to fall in love with asking questions. See, I know I also was used to afraid from asking doubts in the class, from asking questions. I was like, it will feel very, pathetic to ask these silly doubts. But later I got to know that all the people around me had same doubts. They even had worse doubts than me. But I should have asked those doubts. You should have asked those doubts. They should have asked those doubts, right? So the very first thing about studying science, the first step is asking questions, okay? And asking questions, along with that asking right questions, then it's sone pe suhaga. But asking questions is the main thing, okay? So when you are done with asking questions, then we move on to next thing. Then Newton, when an apple fell, Newton was like, why it fell downwards? Why didn't it go up in the sky? So he was like, okay, the question part is done. Then he tested, okay? Then he realized that every time we jump, we come back to the ground. We don't leave the earth, right? So he tested. He threw a pen, it's coming down. He threw a ball upwards, still it coming down. So these are all testing phases, right? Then he moved on to conclusion. Then he concluded that there is something that is pulling all of us down, right? Not other people, not our relatives, but gravity in this case, right? Gravity is pulling all of us down. And that is the main conclusion of where Newton reached, and then he went on to make so many theories that we have to study today, right? So conclusion, but see, I'll tell you one advanced thing from physics as well, right? So Newton said that it's gravity which is pulling things and in the space earth has gravity, and due to that, because of sun's gravity, earth is revolving around sun. But there is very one interesting thing, right? So Albert Einstein G, and he said that, look Newton, gravity is fine, but there is something called space-time fabric. How many of you have heard space-time fabric? Let me know. Let me know how many of you have heard about the space-time fabric. Have you? Have you heard about the space-time fabric? Because if you have, then you are really close to becoming a scientist. Okay, so Albert Einstein G was like, there is this kind of cloth. The space is kind of a cloth, and if, like, see, imagine there is this big cloth and your brother is holding it from that side, you are holding it from this side, and you put a ball inside, it will go down, right? From the center it will go down. That is something what is there in the space. He said it's just a space-time fabric and earth is present in it, and because of its gravity it is going down in the space-time fabric, right? So all those things. So what happened? Things improved. Newton made gravity, Albert Einstein made some corrections, improved it, and told that it's actually space-time fabric, right? So this is how you study science. You start asking questions, then you start testing, you reach to a conclusion, and you make improvements. Okay, done. Next we are going to see in this, yes, now is the time where I want you to give me any questions that come in your mind. Okay, I want all of you to comment in the chats. See, you all play cricket, right? So, like, I'm the batsman. See, I hit the bat, I hit the ball, a ball came, right? I hit the ball and it's in the air. It's in the air, and it can either be a 6, right? Or it can either be a catch out. You are there and you ask me, what do you think? What are the conditions that it will be a 6 or it will be a catch out? What do you think? What do you think will you ask? Will you ask that what is the color of the bat? If the color of the bat is blue, then it will be a 6. If the color of the bat is red, then it will be a catch out. Will you ask that question? Or what kind of questions you all will ask? What kind of questions you all will ask? Give me the extreme questions you can ask. The most random questions you all can think of. Ma'am, what was the color of the ball? Right? Or, ma'am, what was the color of the gloves? Right? So all those kind of random questions, do they make sense? See, the first step was what? Asking questions. So we are trying to ask questions. We are asking questions, right? What was the color of the bat? What was the color of the sticker on the bat? Will you ask those questions? Will you ask those questions? Ayansh Sharma is here. Ayansh Sharma, we have a question for you. Which questions will you ask to think if it's a 6 or a catch out? What do you think? Right, give me the most random questions, any questions. Ma'am, can I know whether on screen marking will there be for 10th standard? See, beta, for this time, for 2026 session, 2025-2026 session, you probably won't have OSM marking. We don't have any update about that. Right? So, but from the next year, they have said that they will have OSM marking for 2027 session. Hi, Divyanshu. Of course, I remember you. How are you, Divyanshu? So, Divyanshu is our class 10 student. He was, when we took live for like 4-5 hours, right? He was there for the whole lives and all. How are you, Divyanshu? How are you? How are your summer vacations going? I remember you told you will be taking PCB, right? Okay, so yeah. Senthil, I'm so sorry if I'm pronouncing your name wrong, but yes, from the next session, if you are in class 10th right now, from the next session you will have on-screen marking. 99% you will have on-screen marking. If there is any change, then CBSE will tell, because there are lots of things going around, right? Ma'am, for 2026 to 2027 will not be there. It will probably be there. It will probably be there. Hi everyone. Great. Divyanshu took PCB. Great, Divyanshu. Very good. Okay. So I was asking you some random questions to throw at me. What are the questions? Okay, so basically the whole point of this topic is asking questions, but asking the right kind of questions. I remember Divyanshu is in 10th class and he asking me questions of quantum mechanics and the laws which I read in masters. So that's how you ask questions, bacha. Right? When you ask questions, you learn that how to ask right questions as well. Okay, so when I talk about a cricket match, you will not be asking questions with which brand of the bat is, right, or which is the color of the ball. Will you ask that? You might ask that what is the quality of the ball, the quality of the bat, but will you ask the color of the ball? I got 98 in science. Great, Devanshu. Congratulations. Devanshu was our one of the consistent student, and you all can see we got 98 in science. Very good, Devanshu. Hi, Sangeeta. How are you? Okay. So, in class 9th also, you have to ask great questions, just like Devanshu did, your senior here. So, basically, you won't ask these kind of questions, right? Amount of the grass on the field. So, of course, if you go into very micro level, you will say that Kashmir willow is better than some random bat made on the street. But you are playing in with your friends. Will you ask the question that which is the brand of the bat? Right? Because we know even players have like sponsored bats, right? So what are the questions you will be asking? What are the right questions to ask? Are the questions like mass of the ball. If the ball is very lightweight, it won't be able to reach to the boundary, right? The air will throw it in the opposite direction. But if it be of very heavy weight, will it reach the ground? Then it won't either, right? So that can be one of the questions that you can ask. Then you can ask the speed and direction in which it has been hit. So we all know, right? The ground of the cricket is not completely round. Right? It's not a round circle. It's sometimes a sphere. Not sphere. It's sometimes an oval ground. Some boundaries are very far away. Some boundaries are very close. Right? So if you hit towards the boundary which is not that big, it's more chances are there that it will be a 6. But if you hit towards a boundary which is like very stretched away, very far, there are more chances that it can be a catch. Right? What is the field position of the players? What was the strength with which the batsman played the ball? Right? So all those things matter more than the color of the bat, the color of the ball. So these are some of the kind of questions you should be asking, the right kind of questions. Right? Ma'am, suggest me some tips for class 11th. Class 11th, beta Divyanshu, see, class 11th is like one of the best classes you can be, right? Because yes, Aditya, you will get notes. I will paste the notes in the description. Do not worry, okay? I will paste this whole PDF in the description, okay? Talking about 11th, you just need to be consistent, Divyanshu. Nothing else. Not a single hack or tips or anything for you. Just stay consistent, open your book every day, try to read, and you will yourself see that you're improving slowly. You will figure out the way of learning that will work for you, okay? Because there can be some specific learnings that worked for me, but it might not work for you because we are two different people, right? So you will have to figure out if you like waking up early in the morning or studying late at night, or in which manner do you like to study. One thing is, do not skip numericals. That is the one mistake I did personally in 11th class. For physics, for chemistry, practice as many numericals as you can. And this is for 9th and 10th class students as well. Practice, beta. Practice and consistency. Nothing else is needed. No Ramban in this whole world can take you to victory if you don't practice and if you are not consistent. Okay, that is it. Okay, so these are some of the questions that you should be asking. The whole slide actually depicts that what are the right kind of questions to ask. Okay, questions asking is very good, but asking the right kind of questions is very, very important. right? If you are asking the color of the bat, you won't reach to the conclusion that you should be reaching. Okay, so ask right kind of questions. Okay, moving on, again we have some language of science. Now, how many of you, can you all write down what are your native languages? Well, I saw some of you are from Uttarakhand, so it can be Garhwali. I don't know others because my friend is from Garhwal. I have my native language as Punjabi, some as Hindi, some as Kannada, some as Tamil, Telugu, right? So all of you have different languages, right? Yes, ma'am, I agree with you. Great, Aditya. Great. You have to agree with me. I am Aditi, so you are Aditya, so you have to agree with me. Okay. So, okay, Divyanshu, best of luck. Okay. So, just like we all have our native languages, science also have its own language, right? What do I mean by science has its own language? So, see, we use power. So how do you say that guy lifts so heavy weights in the gym? He is so powerful. So the power you talk about is the muscular power. But in science has its own meaning of power. It can be used in electricity, it can be used in force, it can be used in classical mechanics, right? So all the different phases of science has different definitions of power. We say force. How much force do you think I should apply to work hard? So force and work have very different meanings in our general conversation. But in science, in physics, in chemistry, in biology, those words have very different meanings, right? Energy has a completely different meaning in science, right? So the science has its own language, just like all of us have our own native languages, correct? See, you know this formula, all of you must know this formula of velocity, right? So velocity is what? Velocity is distance upon time, right? Or displacement. Velocity is displacement divided by time, right? So what is this? What do you call this whole thing? What do you call this whole thing? This whole thing is called a formula. This whole thing is called a relationship between velocity, displacement and time, right? So how do we figure out that this is divided by time? Why the time is in denominator and not in the numerator? So all this comes with a lots and lots of observations, right? A lot of observations. We saw that cars are moving, and when we travel to a particular distance with different velocities, time changes, right? Of course, it's common sense, right? But we have to give it a formula, a scientific meaning, because now we are driving a car. But we talk about time travel, we talk about spaceships, we talk about, so you know, Elon Musk is sending so many rockets. Do you think this is not applicable there? This is definitely applicable there. See, this small formula is applicable in rocket science. So you know how much weight these things have. Although their calculations are really hard, but still these things are applicable there. So what is this? This thing, beta, is mathematics. So in science, this is as important as the relationships are as important as in the, what am I saying? The maths is as important as science, right? What happened? No, ma'am, wrong. What is wrong, beta? Ishant. Why wrong? Yeah, why wrong? It is correct. You are also crying also. Like laughing, crying, whatever. What is wrong? Yes, it is correct. What is wrong? What do you think is wrong? No wrong. No wrong. Okay, let me know what's wrong. We'll correct it if it's wrong. Okay, no worries. Okay, next, so do you understand that how science has different language? Now, one more thing in this I want to add. See, I am sitting here and I tell you, if I tell you that from your school, your home is 5 steps away. Okay, that's pretty much bad, but 5 steps away. Okay, so 50 steps away. Now you will walk steps like this. A 1-year-old will walk very slowly. A 20-year-old might of a 6-foot guy, he will walk and his steps are probably half a meter long, right? So you cannot measure distance in steps, right? In earlier times we used to measure distance in steps, and then one time came and we are measuring distance with this length. So this length, and my brother is like 6 feet tall, so his length of this arm is definitely different, right? So there is no specific, what do you say, unit of distance we have that works everywhere with everyone. Aurangabad distance is equal to 10 upon speed. मुझे लगता है कि ये सवाल गलत है. नहीं गलत है, मैं गलत है मैडम. मेरे एक बार फिर से जान लो, मेरा स्वागत नहीं करोगे इसलिए मैंने जो रंग लिखा मेरा नाम है. अक्षतम, आज मेरा स्वागत करो. Okay, everyone, please clap for Akshat. I don't know what kind of tool you have for this, but welcome Akshat, welcome to the live. Okay, now that's a good way to get the attention. Actually, I actually recommend you. Yes, yellow Akshat. Okay, next we are talking about what? Language of signs. Now we were talking about that the distance, the signs should be same if I'm doing some experiment here and I fly down to Germany and I do the experiment here, or I don't fly down to Germany, I connect with the scientists there and they are doing some experiments and I say, hey, the distance between this whole setup should be 3 steps. Does that make sense? His steps will be different, my steps will be different. So this is not working, right? So we came up with units. What are units? Units are the fundamental quantities with which we measure something, right? Units are smallest quantity, fundamental quantities with which we measure something. Now if I say to the Germany scientist that the distance between this whole city is 5 kilometers, then he will understand that it's 5 kilometers, right? You can change it, the distance to yards, you can change it to meters, but the essence of the distance that you have to cover remains the same, right? Okay, Shant, no worries, right? Correct. So these are all the things that matter. That is why units actually matter, right? So what happened once is, a plane was there. This is like the story from your exploration book. So a plane was flying and let's say the pilot told the instructor who has to fill the fuel that put 15,000. Now 15,000 what? Or let's say before that, your mother tells you to get 5 bananas, and that some makes sense. Let's say your mother tells you get 5 milk. Does that make sense? Does that make sense? If she told get 5 liter of milk or get 5 ml of milk, then it makes sense. Then it makes sense, right? So that ml, that liter, the distance with meter, the distance with kilometers, all those are units, right? All those are units that are used to measure the physical quantities, that is distance, that is weight, that is time, right? Now talking about, coming back to the plane's story. So what happened was, the pilot said that how much fuel needs to be filled? 15,000 or 25,000. So he meant for 25,000 kg. The person came from America, there we use pounds, or I don't know, maybe Britain, there we use pounds, right? So he came and, ma'am, please side, I want to say, yes, sure. So he came and he filled 25,000 pounds of fuel rather than 25,000 kgs of fuel. Now 25,000 pounds of fuel is roughly equal to 15,000. Okay, see, 25,000 pounds of fuel is roughly equal to 15,000 kg of fuel. But the pilot required 25,000 kg of fuel to cover the whole distance. Now we have 10,000 kgs less fuel. Do you think what will happen? In the mid-air, they get a signal that the fuel is less. And luckily, they got some nearby airport and they landed. But what if they were flying above an ocean, there is nothing around, and they'll have to land in a water or some island, they get stuck there. I recently watched the film Send Help. It's great if you want to watch it. So those are the things where these small quantities, these small science matter, and that is why we should study science. You ask, if I want to become a doctor, why should I study sin theta cos theta, right? But these are basic things, beta. You have to go through basics, right? Then only you become you become a specified version of yourself. Even if you want to become a doctor, you have to do the whole MBBS, right? Then only you will move to, let's say, orthopedics is your specialty. Then only you will go to orthopedics. There are thousands of them. So you can ask them directly, I'll directly study about bones. I won't study about the whole of the MBBS syllabus. You can't, right? Because your basics should be clear. Correct. So these comes into basics. So there is a difference between kg and pounds. These are some of the physical quantities. Those are our length, our mass, time, electric current, temperature, amount of substance that we will use in chemistry. This we will use in chemistry. Okay, so remember I told you this. Then luminous intensity is we'll use in 11th, maybe even 11th or 12th. I haven't used it till yet. I've done masters. So the basic SI unit, standard international unit. So that means this is applicable from India to America to Australia to Europe, everywhere. Okay, everywhere these units are same. So if you tell someone in Germany 12 kg SI unit, 12 kg SI, so he will understand how much amount he has to take, right? So these are some of the units. For length we have meter depicted by M, they have symbol M. For mass, kg usually is the SI unit. We have gram, but that is not the SI unit. This is SI unit. Okay. For time we have seconds. For electric current we have ampere. This we are going to study in 10th class. We have a whole chapter on this. Okay, then for temperature we have Kelvin, 230 Kelvin, 300 Kelvin, 273 Kelvin is 0 degrees Celsius. You have something new to learn about. Amount of substance is mole, that is represented by simply MOL. We will study about that in chemistry. So see, everything here is related, right? Okay, moving on, we have we'll study just 2-3 more things. Okay, the live will go a lot longer if we continue this. Okay, we are just enjoying our summer vacations. Let's enjoy the summer vacations. Do not worry a lot about, you shouldn't waste the summer vacations, but you should not also waste the summer vacations in just studying. Okay, so laws, there are Newton laws of motion. There are other laws of motion which are applicable on force. There are Gauss's law, you will learn in 11th class. There are so many laws in science, so many laws in physics. Mass law. Okay, so what exactly is this law? What exactly is this law? Is this the law that we use in courts? Is this the law that we use, that are used by judges? That is not what this law is. This is a science law. As I told you, science has its own language. So law maybe means something else, but in science it means something that we describe what is happening in nature, right? What is happening in the nature and is often in a fixed pattern. That means if I am jumping, I always come down. If you jump, you will always come down. No matter wherever you are on this whole earth, you will come down if you don't like jump so high, right? that you leave the gravitation of earth. But if right now you jump, you are always going to come down, right? That is gravitational law, right? That is gravitational law. So this law describes what is happening in nature in a fixed pattern. So I am always coming down. It's a fixed thing. I will always come down, right? Similar, that is given by Newton's law of motion. Explain the jerk felt when a bus stops suddenly. So wherever you are, in Germany, in India, in Australia, whenever the bus will put brakes, you will go in front, right? You will, no matter where you are. So that is Newton's law of motion. It is applicable everywhere, right? Then the thing is theories. So what are theories? Theories, how do you explain theories? Theories. Okay, so scientific theory explains, see, I told you there is a law, that's gravitational law. Now theory will explain everything about that gravitational law. The force felt, the gravitational force that's pulling us down, the force that is pulling two bodies towards each other. Okay, do not, why are you guys fighting in the live chat? Okay, you got 98.6% in 10th, Ishant. Then what are you doing in the live session of 9th class? Okay, so theories are, they will basically explain the whole law, how that law came into existence. We know that gravitational law came into existence because an apple fell from the tree. What is that? That is a theory told by Newton, right? It told us how and why something is happening, how and why that apple is falling down is because of the gravitational force based on strong evidence. So you jump and you come down, that is a strong evidence, I think, right? So the atomic theory explains how molecules are formed. So we know that atoms come together and form molecules, right? And this is true for everywhere, but the theory explains everything, how the electrons overlap, how they attract, how they repel, what kind of molecules will form from what kind of atoms. So they will tell you everything, and that is a theory. Okay, and then the last thing for today's live, principles. So each one of us has some principles, right? Now Aditya has a principle that he don't want to be disturbed in the live chat, right? That is true, he will abide by that. We have some principles that I will not cheat in the examination, or we have a principle that I will not tell my answers to anyone, I will not let them cheat. That is a principle, right? It's a general rule for us, correct? It's a general rule or idea for us, right? And that will be applicable everywhere. If your teacher knows that Aditya does not cheat in the exam, it is his general rule, it is his principle that I won't cheat in the exam. Then if someone complained against you, okay, Ishant came and he complained that Ma'am, Aditya is cheating. So a teacher will like, no. I know Aditya is a good person and Aditya will abide by his principles, right? So that is the general rule you have. And what idea it gave it to your teacher? It gave an idea that even in a different condition, your teacher chose to trust you, right? And not Ishant, okay? So in science also we have some principles. So the principle is a general rule or idea that helps understand and apply science. It helps us to apply science in different conditions. Let's understand. So do you know the principle of conservation of energy? It says that energy can neither be created nor be destroyed, but can be converted from one form to another. Now let's say an example of climbing the stairs. Okay, I ate food and I'm climbing the stairs. So what is happening? That food went into my body, some chemical thing happened, biology happened, and that chemical, I got energy from the food, right? That chemical energy got converted into muscular energy, and I am able to climb the stairs, right? If I hadn't eaten, let's say I have not eaten in 2 days, will I have enough energy to climb the stairs? Not the same as when I'm eating good food, right? So the more energy, the more chemical energy is there, the more muscular energy is there. The less chemical energy is there, the less muscular energy is there. That means this conservation of energy helps us to explain the laws, the principles in some different condition, that is climbing of stairs. Understood? Understood, everyone? Great. Now this whole chapter, let's do one more live for this chapter. Okay, you will see so many good things. I have few good things in this chapter left. There are some questions we will do. So basically, law is what is happening. Let's just give it a quick summary. Law is what is happening, Newton's law. Theory is why it is happening, that is your atomic theory. And principle is general rule, conservation of energy. Okay, now we have this prediction thing. We will, how do we predict things, how science is connected, and all those things, right? Now all of you do like the session. You are all have been very great. I know you have been enjoying your summer vacations, but do not just waste them in one go, right? Study a little bit. That's why I haven't taken this live so long. Okay, so all the best for your summer vacations. Go roam out, study a little bit in between, and we will meet you in the next live. Okay, everyone? Okay, great. Tata, bye bye, everyone. Love you all.